Hello students, in this video we want to learn about the most important part of Huygens wave theory, that is the Huygens principle. But before beginning this concept, we need to learn about a very important term, that is wavefront. Let us understand this with the help of a very simple activity. Suppose that there is a lake having completely stagnant water. Now, if a stone is dropped in this lake, then waves or ripples will start spreading radially outwards. These waves are going to be in the shape of concentric circles. Let us focus on any one such circle. Then we can clearly observe that all the particles in this circle are oscillating in the same phase. And this is what we call as a wavefront, locus of all the points that are oscillating in the same phase. There is one very interesting and very important property of wavefronts which we can observe here. The direction of waves was radial, and we know that for a circle, radius is always normal to it. Thus, we can conclude that the direction of propagation of wave is always normal to the wavefronts. We can verify this for some other cases also. Suppose that we have a point source of light. Then it is going to emit waves in all the directions uniformly. Thus, the shape of the wavefronts is going to be concentric spherical. And once again we can see here the direction of propagation of wave is normal to the wavefronts. Another example that we can take is of a line source. The wavefronts for such a source are going to be coaxial cylinders. And once again we can see direction of wave propagation is normal to the wavefronts. Now let me ask you a question here. Is it possible to have plane wavefronts? And if yes, then in which situation? The answer is yes, indeed it is possible. We can have plane wavefronts and they will even be parallel to each other and equidistant from each other. It will happen in the case when the incident light beam is parallel. Or we can also say that when light is coming from a faraway distant source, then the curvature of the wavefronts is so large that the wavefronts appear to be nearly planar to us. So now that the concept of wavefronts is completely clear, let us go ahead and move on to Huygens principle. The role of Huygens principle is essentially in finding out how a wave propagates by drawing the shape and position of wavefronts. And this is achieved by doing some geometrical constructions. So let us see the statement of Huygens principle, and simultaneously we will also see how it is applied. Huygens principle states that each point of a wave behaves as a secondary source and thus emanates waves in all the directions with the same speed as the speed of original wave. These waves are known as secondary wavelets and their wavefronts will be spherical in shape as the source is a point. Now, if we draw a common tangential surface to all these spheres, then we get the new position of wavefront at a later instant. So suppose if we have a spherical wavefront at t equal to 0 and we want to find out what is its new shape and position after time t. Then, as per Huygens principle, each point on the wavefront can be treated as a secondary source. Therefore, it starts emitting spherical waves. Thus, we will draw spheres having radius r equal to v into t, where v is the speed of light or speed of the wave. To find the new position, then we have to draw a tangential surface to all these spheres. As we can see clearly, the tangential surface also comes out to be a spherical surface. And this is how, using Huygens principle, we can locate the new position of the wavefront. But there is one small problem here. Since the secondary source is a point source, it will emit waves in all the directions, including the backward direction. and this will result in a back wave which is physically not possible. Huygens justified this by saying that the amplitude of secondary wavelets is maximum in the forward direction, whereas it is zero in the backward direction. Although he was never able to prove this mathematically why this happens. Many years later, scientists were able to indeed show that this is true, and in fact the back wave will not exist. So this completes the concept of Huygens principle, and in the upcoming videos we will see how we can explain various optical phenomena using this principle.